Welcome to this video lecture. This is Mark Scythian, FAA licensed aerospace technician, airframe, power plant, and avionics certified. The date today is July 6, 2016. I wrote this little lecture excerpt here describing the function of the turbocharger and supercharger and their differences and similarities, followed by pictures and diagrams to illustrate the text. So I'll start at the beginning here. Reciprocating piston engines that are naturally aspirated are dependent on atmospheric pressure to draw in air into the cylinder during the intake stroke. Typically without some type of forced air induction blower forcing air into the intake of the engine above atmospheric pressure, approximately only 80% of the cylinder's air capacity will be met. This does not allow the fuel charge to burn at its maximum potential, causing unburnt fuel to exit the engine's exhaust port and manifold. By installing a forced induction air pump into the intake of the piston engine, combustion efficiency will increase, allowing more fuel to burn effectively and efficiently, maximizing fuel burn during the piston engine's power stroke. A turbocharger is a forced air induction pump which consists of a turbine connected to a centrifugal flow compressor disc in which the power to drive the turbine is taken from the engine's exhaust waste heat, allowing power in the form of what amounts to a power recovery system. You're taking waste heat and using that to power something else that enhances the engine's performance instead of letting it go out into the atmosphere. The 33% loss out of the exhaust in the form of waste heat purge velocity is directed towards a turbine, which then drives an airflow compressor to push air into the engine's intake, increasing combustibility of the fuel without using any crankshaft brake horsepower to do so. So about like the late 1800s, 1900s, the turbocharger was invented, and this is kind of where the jet engine concept came from. You know, the piston engine turbocharger. You have a turbine being driven by hot gases to drive an air compressor. Kind of sound familiar, right? So, you know, they just set it up with a combustion chamber in between the turbine and the compressor. But anyway, the idea is to get more airflow into the engine. So the original idea for the jet engine kind of came from the turbocharger. So as for a supercharger, the same is true, except that the supercharger is driven by the engine's crankshaft via a belt drive connected to the supercharger forced air induction compressor, and has no turbine as a drive system to power the compressor, but instead a pulley connected to a belt driven off the engine's crankshaft. Superchargers are practical when closer to sea level, as to where there is sufficient atmospheric pressure, but with higher altitude piston engines such as piston driven propeller airplanes, the turbocharger is more effective since it will not take from the engine's horsepower as it climbs higher where the atmospheric pressure is significantly lower than near sea level. So it's already compromised with low atmospheric pressure at high altitudes, and then you're going to take more power in the form of a supercharger? I don't think so. So that's why you have turbochargers on piston powered airplanes, because you kind of need it when you fly anything higher than, I'd say a mile above sea level. So automobiles powered in gas piston engines that operate at high altitude, such as Denver, Colorado, which is over 5,000 feet above sea level, require turbochargers to operate properly, since the atmospheric pressure is considerably lower when a mile above sea level compared to sea level. A piston engine operating at such high altitudes will have to operate at higher RPM and lower gearing in order to draw in enough air in order for the engine to develop enough power and move the automobile properly. But with a forced air induction system taking its power only from the waste exhaust to drive the forced air induction into the engine, then there is a return back to the engine, allowing enough airflow to enter the cylinder, especially when under lower atmospheric pressure. As for both high performance racing and conservative throttle settings, the turbocharger and supercharger allow for more airflow into the cylinder, allowing for more fuel to burn, so that higher performance driving is achieved with lower fuel economy, as well as conservative driving with higher fuel economy. So if you want to burn the fuel, you get to burn the fuel with more air, right? So the idea is if you want to go racing, you don't really care about fuel economy, you just want power. So it's going to burn all that fuel up. But let's say you're looking to drive really conservatively. Well, you don't need much fuel, and of course if all of it's burning because you got the air to do it, you're going to get better fuel economy. So it will enhance the driver throttle selection, the turbocharger or supercharger. You know, it depends how you drive with it, you know. So the idea is to burn most, if not all, the fuel charge during the power stroke with increased airflow greater than just from atmospheric pressure. The turbocharger and supercharger serve their purpose when maximum amount of air enters the cylinder so that volumetric efficiency reaches 100%. So if you have like so much cubic inch displacement and a majority of that's got to be air, like say 12 to 1 air to fuel ratio, whatever that is in fractional ratio, you're only going to get 80% of that for air under just atmospheric pressure. But if you have a forced air induction blower, then you're going to get all the efficiency you need in terms of airflow. We're talking just the volumetric efficiency. So that's the ratio of the amount of air divided by the required air for maximum combustibility in relationship to volume displacement. So on the turbocharger turbine is a valve which regulates the amount of exhaust gas into the turbine called a wastegate, which is controlled by a bellows system which governs by expansion or contraction in relationship to atmospheric pressure. This could also be an electronic solenoid governed by atmospheric pressure or a mechanical solenoid as well. The idea is not to underboost or overboost airflow, but to keep the airflow in the cylinder close to the maximum potential airflow or 100% volumetric efficiency. Anything more or less than 100% will either not allow the turbocharger or supercharger to serve its purpose, or will cause overboost to the cylinder and can potentially damage the pistons and cylinder head. See the diagrams and pictures of the supercharger and turbochargers. So on the supercharger, since it's engine driven, you're going to have a regulation system on the output of the compressor side, kind of doing what the wastegate does with heat going to the turbine. So now let's look at the pictures. We have ourselves a turbocharger here. Here is the engine intake on the top, and then here's the exhaust manifolds. So airflow goes in, drawn in, compressed with fuel, ignited, compressed power, exhaust. So that exhaust wastes heat. That's at least 1/3 of the energy in the fuel. But instead of just going out to the atmosphere, it then goes to a turbocharger hot section, the turbine. And this turbine in here then drives the compressor to draw in ambient air from the outside, and then it compresses it through centrifugal compressor disc to a diffuser, and then out back first through an intercooler, which, remember, when you compress the air you get heat. You might get a several hundred degrees temperature rise from that compression, so it's got to go through an intercooler to expand and drop the temperature, and then bring that pressure back up into the engine, to the intake, because you don't want too hot air going in, but you want some temperature rise. So basically it takes the energy of the exhaust gas flow to drive a turbine, which then drives the compressor, and then the airflow is sent to the engine to increase the burnability, combustibility of the fuel, because now you've increased the air charge from 80% maximum capacity to 100, and then you're able to burn the fuel better, right? So that's the turbocharger, and here's a picture of one. There is your hot section connected to the exhaust. This exhaust gas drives the turbine right here, which drives the centrifugal flow air compressor. Air draws in, and then it's compressed and pushed out into the engine's intake. As for the supercharger, same thing, except no turbine, and the centrifugal flow air compressor is driven by the engine itself through a belt. Same thing, and you're going to have some regulation so it doesn't over or under boost. And then here's a picture of one. No turbine there, remember, it's got a belt drive, and then you got the centrifugal flow compressor. It draws in air from the other side inward, slings it through the diffuser and sends it out to the engine. So you can get away with a supercharger at lower altitudes, of course. But, you know, there is a pro and con to everything, right? So the turbocharger, you know, now they're automatic wastegate actuation, so you won't overboost and burn your turbocharger out, but still you're going to require some maintenance on the turbocharger more than with a supercharger, because you also have like oil going through it, you have the heat, and eventually you're going to have more wear and tear on the turbocharger over the course of time, so there's going to be more maintenance involved. But supercharger, you know, it's pretty much like driving any other accessory. It's not going to be under all this heat like an exhaust system will, so you have less maintenance, of course. And then of course there are electrically powered superchargers which tie into the engine based off battery output. They're not connected by a belt, but still you're taking some type of power, in that case electrical, and so the alternator's got to work harder, but you know, to charge that battery. But if you just take the mechanical power out of the crankshaft, either or, electrical or mechanical supercharger, you know, overall over time you're going to have probably the same wear and tear overall. But you know, depends how well the materials are made. If you had an an electric motor driving a supercharger connected to the battery, and it was a high quality brushless neodymium motor or something, you know, DC, like a brushless DC motor, then yeah, you'd probably get a lot of time on it, but still subject to wear and tear. So it depends what you're doing, but if you're going like for all altitudes up to maybe a mile or so, it's best to stick with the turbocharger, because you're taking advantage of that waste heat and you're not taking any power out of the engine that would normally be lost out of the exhaust. So thanks for watching this video. I wanted to explain the difference between the turbocharger and the supercharger. So important in the field of piston engines, and that was an appropriate video to add to this YouTube channel video library. So thanks again for watching, and have a great day.